My name is Phil Walker, and I'm CEO of Transcend Robotics, and we're bringing mobile robotics into our everyday lives. I did a BS in computer science at Fordham University. I was always into robotics. I took some robotic courses. After that, I went out and I became a product managing analyst at an analytics company. And at nights I would kind of tinker around with robots. Transcend was founded on a double patented technology called articulated traction control. And articulated traction control is essentially a novel joint that's limited in the upwards and downward angles with a suspension shock that always makes sure it has consistent traction on the ground. And this technology has essentially allowed our systems to overcome obstacles such as international stairs and other obstacles up to 18 inches without any pre-positioning. 3D printers, CNC machines, were very important when we got started. They were much more earlier stage than they are today to be able to manufacture these, essentially joints, right? Because it was technology, we had a mechanical technology that we had to develop from scratch. The inspiration really came from after the Fukushima event, where the traditional robot mobility designs out there had employed for the last 30 years this flipper design. And it was basically a solution for the military, tactical people who were able to afford such solutions because they required so much software and actuators driving the price up. And because those markets were the usual bidders, I believe innovation kind of stalled there, where it was accepted to be like the solution, and everyone else kind of looked at it. The robotics industry, which is primarily dominated by the research institutions out there at universities, they were all going for the moonshot ideas, which quite frankly, as we've seen in the news recently, are 10, 20, 30 years away from having bipedal autonomous robots from being commercially ready to be consumed. So we kind of took a novel approach. We didn't throw more software, more money, more actuators at this. We actually leveraged, almost as if we've leveraged physics to help us, and kind of bio-inspired designs to help us just hit that first obstacle, articulate over it, and you just move forward with this tech. Today we work with tactical organizations, construction, mining, so 3D scanning and mining. We're working with virtual reality companies. We're working with some automated technology companies. So one industry that I think has had a lot of tough breaks recently in the last 5 or so years has been telepresence. Although that might not be necessarily an industry, it's a vertical within manufacturing, industrial, healthcare, where traditionally the technology has been employed in wheeled robots that can't get over obstacles. And those marketing environments that are applicable to flat environments, those markets are usually healthcare, education, very highly restricted budgets, not very large budgets at that. But when you are able to get over a 1-inch to 2-inch obstacle, I mean, everything opens up, right? You can go to industrial, utility, you can go to construction markets. You can, of course, go to the off-terrain markets, such as farming, agriculture. And mobility is one of the biggest limitations to expanding those markets. I believe that autonomous systems are going to begin helping us in everyday situations to make the dirty, dull, and tedious jobs, just make them obsolete for humans. And RD's technology is the perfect technology for that, because it takes the barrier of entry for those complex software operations out of the loop. So we can now focus on data collection, bringing that arm to where it needs to be to perform that function.